Hello and welcome. So in this video we are going to build momentum trading strategy with cryptocurrencies using Python and Binance. Let's take a look at what we are going to do in detail. So first we are getting monthly crypto prices over the last 3 years out of a universe of more than 300 cryptos. Then we are determining the top N performers over the last M month. So in easier words, as an example, I want to know what are the top 5 performers over the last 6 months. And then I'm buying those top performers and hold them for 1 month. So I'm holding this portfolio out of the top performers over the last M month for just 1 month and see how this portfolio was performing. Then we are backtesting it and see if we're getting interesting results. Spoiler, yes. So you need some prerequisites. First of all, you should watch one of my momentum videos on stocks. So I'm slightly deviating here in this video, but it should be a good foundation to understand what's going on here. Then you should know the difference between return and log return calculation and how they are calculated in Python. And you should also know how to pull prices and other data from Binance. I've covered that in many previous videos, so I will just fly over that in this one here. Everything you need will be linked in the video description. Upon disclaimer, cryptocurrency trading is bearing a huge amount of risk. It may result in total loss of invested capital. Cryptocurrencies are not regulated and the Python Binance API wrapper is not official. This video is not an investment advice or a recommendation to trade this strategy and should be taken for educational purposes only. Alright, so let's get started. As you see, I already did some stuff here. This should be nothing new to you if you've watched my previous video, so I recommend to check that out. We need some libraries, pandas for data handling, the Binance client, which I'm also instantiating here to get historical prices from Binance, NumPy to calculate log returns, and this one enables us to jump from 1 month to the other. I was using a similar one, month end, in my momentum video, and I'm going into more details there, but we'll come to this once we are using that again. All right, so this list here, all Binance symbols, is containing all coins in relation to the USDT, right? So we have Bitcoin, ETH, BNB, and so on, right? So we are considering 329 coins. In case you're wondering, well, how do I get that? I have explained that in my previous video, was just storing that in a CSV, and this one I'm just reading in here. So again, nothing new. This function here, I've also covered in the previous video. So this is just getting K-line data or candlestick or OHLC data from Binance for a given symbol on the 1 month time frame, starting in the beginning of 2019 until the end of 2021. These are necessary data manipulations. So this is just filtering for the time column and the close column, and it's renaming those columns. So this time I'm naming the column after the symbol. Makes stuff easier when we are concatenating data frames. You will see in some seconds or minutes. Then I'm setting the index of the data frame to the time column, and I'm converting the Unix formatted index to a human readable index. And this one is converting the close column to a float value so we can do calculations. So the easiest way to show you what this function is doing is by simply calling it get monthly data. Let's just check it out for Bitcoin. And you will see that we have monthly prices for the Bitcoin here, right? Starting 2019 until the end of 2021. What might be unlucky or even a bit confusing here is that these timestamps are showing the beginning of the month, even though these prices are end of month prices. The reason behind that is a technical thing. So I'm pulling the timestamp of the open here, and the open of a monthly candle is the month start, right? I cannot just pull the timestamp for the close, because then you could run into the issue that a certain coin is closing in the mid of the month due to delisting. Just try it out. Try it out by pulling the close timestamp. You will see that you're running into that issue. What you could do here is to just transform these timestamps to end of month timestamps in case this is confusing you, but we are taking it as it is, right? So let's get rid of this and let's loop over all Binance symbols and pull monthly data, and we are storing that in a list, and then we are concatenating those to get a merge data frame containing all close prices for all coins. So similar as in the previous video, I'm creating a list here, then loop for coin in all Binance symbols. So we are looping over all coins and append the output of the function to this list, get monthly data of the coin, right? And this is taking some minutes. And after some time, the loop went through. So let's take a look at what we got. As you see, we are getting a list containing data frames containing monthly prices for each coin here, right? So let's concat all the items in this list and make one big data frame out of those single data frames in the list. We can do that by using the concat function of pandas. So we are calling that merge data frame and use pd-concat, provide our list and set the axes to 1. And with that, we're getting a beautiful data frame containing monthly prices for all coins here, right? And next, we want to calculate returns. So we can apply a simple PCT change function on this data frame to get monthly returns, as we have monthly prices. So monthly returns is simple, the change between those prices. So we can use PCT change and store that in the reddf, so return data frame. And we are ending up with a data frame like that containing monthly returns. We also want to calculate log returns. So you can work with returns actually, but to speed things up, it's better to calculate log returns here. So I'm creating a log return data frame as well. Use numpy log, provide my return data frame and add a 1 to that. And with that, I'm getting log returns. Right? So I've explained that in other videos. What is the reason behind that, why you would do that. In this video, it's simply because calculating rolling log returns is way more efficient than using normal returns, working with lambda functions, working with products and so on, in case you are interested why I'm doing that at all. Anyhow, next we want to calculate the top performers over a certain window on a particular date. Therefore, let's define a function top red for top performer return. And this function is taking 3 arguments. First one is the window we want to go back. So this is just the look back period. So if you want to consider the return over the last 2 months, you're defining 2 here. If you want to consider a year, you define 12 here and so on. Top n is just a number of coins you want to include. So do you want to take the top 3? Do you want to take the top 5? And so on. And last but not least, the date for which you want to check that. So you need a reference date from which you want to go window month back, right? And first of all, we are calculating the return of the lookback period, or the return of the window you are defining. So we are calling that red window and use the log return data frame, roll over that, provide the window and just take the sum out of that. That won't be possible with normal or with just returns, right? Because then, as I just said, you have to apply a lambda function taking +1 and takes the product out of that, which is quite inefficient. So log returns are way more convenient here. Then we are defining a return series, which is just taking the window return for a particular date, right? So it's rolling over all dates, is providing you the window return, but we want to have the return of this window on a given date here. And this is the red series providing. And with that, we can find our top performers by just taking the return series and consider the n largest and provide our n here, right? So again, what are we doing? We are rolling over the log return data frame, calculate the sum of the returns, which we can only do because we have log returns. Then we are screening for the summed up return on a particular date, which we are providing to the function. And then we are just checking what are the top performers on that date, right? And now the only thing we have to do now is to check, okay, how are these top performers are performing the next month? Because we are buying a portfolio out of this, let's say 3 coins. And now we want to know, okay, if we are holding that 1 month, how did the portfolio perform? So we need the mean return of those top performers here, right? So let's call that perf red. And now we are using the normal return data frame and log for the top performers name, which is just the date, right? So this is just the date we have provided to this function, right? And we want to screen the return data frame now for the next month return, right? So we are taking the date we have provided to the function and add month begin 1. So we are just going from this month beginning to the next month beginning. So let's say we have the top performers as per January. Then we are checking, okay, what is the return of our portfolio in February, right? And to screen for the actual top performers, we are also providing top performers index, which is containing our names for the top performers. So names are just the coins, right? And after that, we have our returns, and we just want to have the mean return out of our top performers, right? And that's already it. Then we are returning this value. So return perf red here. And now let me show you how this is working. So if we are calling that top red, take a look back window of 2 months here, consider top 10 performers and check that for, let's say, beginning of 2020, we are getting a portfolio mean return of minus 12% here, right? If we would check that for the 1st January 2021, we are getting a mean return of roughly 50%. Okay, now let's get to probably the most interesting part, how would this strategy have performed over the last 3 years. Therefore, we are using this function and we are just looping over all dates, right? So I'm creating a list here where we are storing our top performer returns, and we are simply looping for date in, and then we can just take our return data frame index, which is containing all our dates. But we are skipping the first date because simply we cannot go 1 month back, right? Because we don't have data before that. And we are also skipping the very last date because we don't have a date to look for after the last date, right? Because we don't have a January month end return yet. And then I'm simply appending to the profits list the function call top performer, and now we have to provide some parameters. So let's check for, let's say, going back 7 months, taking the top 5 performers for the date in the loop. So top right, sorry. So let's take a look. So these are our returns. So we can do a quick analysis here, pulling that into a series, taking a look at the mean profit, 12%, max profit, wow, 111%, max drawdown, 37%. So of course a lot of risk here involved. But now let's do one more thing, and that is not only looping over a certain window, but let's loop over a window range just to find good windows. So of course you can also loop over the top end performance, but this is nothing I would cover here, just to give you an idea how you can use that to do some nice analysis. So I'm creating a matrix here and just use a range for windows. So let's just take 1 to 12 windows, so that we have 1 month until 12 month look back periods. And let's just extend this loop here. Loop over the windows and call the function on the window, then append the profits to the matrix, and after this outer loop was running one time, we have to reset the profits list. Right, so what is this construct doing here? It is calculating our top performers over all dates, but also over a given window range. Right, so I think that's a pretty interesting thing to check. So let's take a look at what we got here. So now we have to create a data frame out of this matrix, and the index is our windows. So let me show you what I'm talking about. So here you see the windows, right? 1 to 12. And these are just the dates. So first date, second date, third date, and so on. So in case you're wondering about the NAN values, they are simply there because we are taking a certain look back period and we don't have data for this look back period. So this might be a bit counterintuitive, because when only going 1 month back, why do we have data here? But this is because we have restricted the loop here, right? So if we include the very first date, you will see that we are getting a column full of NAN values here, right? So, but I think it's not necessary here, so I'm excluding that. Anyhow, let's wrap that all in a variable. So let's just call that all month here. And let me quickly show you how I'm calculating the cumulative returns now. So you see we have mean returns, so not log returns, but mean returns here, right? So simple returns. And we have a mean return for each date here, right? So to get the cumulative return, I can simply take the product of each row here. And this is exactly what I'm doing in the next step. So I'm adding a 1, take the products and do that on axis 1 to get the row product here. And afterwards subtract a 1. And with that, I'm getting a series containing the cumulative returns over different look back windows, right? So 8 month would be the best pick here, right? So a lot more possibilities, a lot more analysis options here, what you can check. But I think that's good for now. So if you're interested in a more in-depth analysis, feel free to let me know. So I personally would be quite interesting if this is also working on lower time frames, which would then again be an interesting thing to let a bot do the work for us, right? So if you're interested in that, let me know. Thank you very much for watching, and I'm looking forward to seeing the upcoming videos. Bye bye.